Hey everyone, it's Chris from chrisbeatcancer, and today I'm interviewing the legendary Dr. Valter Longo. Dr. Longo was born and raised in Genoa, Italy, and received his undergraduate degree from the University of North Texas, where he majored in biochemistry with a minor in jazz performance. He received his PhD in biochemistry from UCLA and did his postdoctoral training in neurobiology of aging and Alzheimer's disease at USC. Dr. Longo's studies focus on the fundamental mechanisms of aging. His laboratory has identified several genetic pathways that regulate aging and reduce the incidence of multiple diseases in mice and humans. His laboratory also described both dietary and genetic interventions that could reverse the course of diabetes and Alzheimer's and protect cells and improve the treatment of cancer and other diseases. Dr. Longo's most recent studies are on dietary interventions that can affect stem cell-based regeneration to promote longevity. Dr. Longo is recognized as a global leader in aging and nutrition with over 100 peer-reviewed publications in major top journals like Science, Nature, Cell, Cancer Cell, JAMA, Journal of Translational Medicine, and more. He is recognized by Time Magazine as a longevity guru with 3 feature articles in less than 2 years. So now you know why I'm excited to talk to Dr. Longo. So, hey, Dr. Longo, thank you for taking the time to do this.
Hey, Chris, you're very welcome.
So I'd love to start with how you transitioned from aspiring jazz musician to, longevity expert.
Well, I'm not sure. I always wanted to be a musician, and then whenever I encountered some issues, which was they asked me to direct a marching band back in Texas in the university, and I wasn't going to do that. I was a rock musician.
Yeah.
And then I thought, what do I really want to do in addition to playing? Of course, I kept playing, and aging came to me immediately. I just loved the scientific challenge, but I also thought we'll have so many solutions for diseases, both prevention and treatment. I mean, at the time, I had a very vague idea what that meant. But yes, since I was 19 years old, all I've done is study aging and age-related diseases. So that's my passion for sure.
Was there a light bulb moment that got you interested in that?
In the book I talk about, and these are cliche things, right? My grandfather, but in fact, I was in the room when my grandfather died, and I never thought much of it. But I think, being 5 years old and seeing somebody die probably sticks in your head, and it's something that, becomes like your major issue all of a sudden. And then I think at 19 was the first opportunity to say, you know what, maybe I will just study this, why do people die? So that's, I imagine, I don't know, but I imagine that's what it was because I was so sure, that's what I wanted to do from a music major to that. It seems like a little bit of a strange switch,
Did your grandfather die relatively young, or did he live to be 90 or...
Well, I mean, relatively young. He just had a hernia, actually, and it wasn't treated for years and years and years, and doctors suspected that was what eventually turned into a tumor, and that's what he died of. So I think, also something was in my head, the fact that, and I think the family was fairly aware of that, and the fact that they could have probably avoided this by just a simple, surgical procedure, which he didn't do, and so that stuck in my head too. And that's why in the book I talk about him and his next door neighbor Salvatore Caruso, who ended up, being one of the oldest people in the world, and now they probably had the same diet and probably the same longevity potential. And Salvatore Caruso made it to 110. But just because of that maybe bad decision of not going to the doctor and getting surgery, that might have cut 30, 40 years of his life.
I understand, absolutely. So will you tell the story of Biosphere 2?
Yeah, Biosphere 2, I was lucky enough to eventually work with some of the world leading figures in aging. One was Caleb Finch, USC, but the other one was Roy Walford at UCLA, and that's where I started my PhD. And Roy, when I first got to the biosphere, to UCLA, it was in the Biosphere 2. And Biosphere 2 was this place in the desert of Arizona, was basically a sealed environment where he and other 7 people went into to begin the first, I think that was the first calorie restriction human study. So they were in there for 2 years. Most of the time they were calorically restricted, meaning that they ate about the very minimum that you can eat and stay alive, pretty much.
So they were basically in this dome, trapped in this dome for 2 years together, and they had to grow their own food inside it, right? And was the main goal of the study calorie restriction, or were there other things they were trying to ascertain from doing that?
No, calorie restriction was not supposed to be part of the study, right? They were supposed to go in there and do all kinds of studies on humans kept in a sealed environment, and maybe it was an idea about space stations or something. I think that's probably what it was. But Walford, I think, had an agenda from the beginning. Of course, he was the world leading expert on nutrition and longevity. And particularly calorie restriction. So I think he was looking for an opportunity to do that, to do a human calorie restriction study. And sure enough, he succeeded. And if you look at the results, are amazing. But eventually, we found out that that kind of calorie restriction causes as many incredible solutions as much as it does cause problems, right? And
how many calories were they eating per day, roughly?
I think the average was 1,800 calories. If you look, I always show the picture of Walford when he was calorie restricted in Biosphere 2, and he looks emaciated. He looks like a skeleton. So clearly, on one side, you see the effects on blood pressure. I think they had blood pressure like 85 over 55. And then the cholesterol extremely low, and the blood glucose was extremely low. So you look at them and you say, this group will never get cardiovascular disease, will never get diabetes. And sure enough, the monkey study confirmed that. And they probably get a lot less cancer, they were so pushed to such an extreme that they probably end up dying of other problems. And Walford himself died of a motor neuron disease. I mean, nobody knows, was the biosphere involved in causing this? But certainly a lot of people suspect that being pushed to the limit that he was in his late 60s could have contributed to eventually developing this motor neuron disease, So that's the trick, that's what I've been trying to solve for all these decades, since the Walford years. How do you get these incredible benefits of calorie restriction without the problems of calorie restriction?
What were some of the other, before we move into your research, what were some of the other, some major findings from that study? Like the big revelations? Is it just the calorie? Yeah.
The Walford study in Biosphere 2?
Yeah.
Yeah, I think, they couldn't do what with Weindruck, which was also in the same lab a few years before me, Richard Weindruck, who ended up doing the monkey study at the University of Wisconsin. So they couldn't do a longevity study. But if you look at the blood markers, it was very obvious that these people would very unlikely develop any cardiovascular or disease or metabolic disease. So I think those were the major findings. There was only 8 people, but I think later on there were larger studies done, and they all confirmed what was shown by Walford in those original studies.
While we're talking about blood markers, there's a lot of debate about cholesterol. And I would like to hear from you what you think the ideal range of cholesterol is.
Well, I don't know. I mean, I didn't review the literature on cholesterol, but certainly the below 200 is the healthy range, and of course probably if you look at Biosphere, I think it was 125 or something like that. So it was much lower. I think I probably wouldn't go try to push it too low, as we've seen for IGF-1, for example. IGF-1 insulin, like growth factor 1, is certainly associated with aging and diseases, age-related diseases, particularly cancer. But we see that people that are in the very low range, they tend to do worse, probably because that is a marker of frailty, meaning that if somebody has a cholesterol that is too low, you have to start wondering is something not working properly, right? I mean, we make our own cholesterol, and why is the body all of a sudden not making any cholesterol? So, I mean, we have to be careful at demonizing things. So it's good to be very low, and eventually, maybe when you get to too low levels, whether it's IGF-1 or cholesterol or triglycerides, then you have to wonder, is something wrong with the system? Is this person pushing, and this is very common with people that do dietary interventions, they take something good and they make it bad, right? They push it to such an extreme that then they go from one problem to the other. And let's say proteins, right? We publish on protein, and I'm assuming we're going to talk about it.
Yes, definitely. Please do.
But you can go from high protein, which is a clear problem, to very low protein intake, which is another clear problem. And that's very, very common.
One of your studies, probably one of your most or more well-known studies, is related to protein and protein consumption tripling or quadrupling the increased risk of mortality before age 65. Is that right?
From cancer mortality.
From cancer, right?
Yeah. Overall mortality, I think, was 75% in the up to age 65.
So the high protein diet, people that are, and by high protein, you mean eating animal protein 3 times a day, right?
Yeah, this was over 20% of the calories coming from proteins in a American population that generally had a very high calorie diet, right? So high calorie diet with 20% of the proteins, the calories coming from proteins. So you're looking at 600 calories coming from protein. So yeah, very over 600 calories coming from protein. 600 calories coming from protein. So yeah, very high levels. And this was compared to the people that had less than 10%.
And those were people eating a plant-based diet, correct?
Not necessarily, but they had
just very little.
Very low protein intake. Now, if people had a relatively high protein intake, but it was from a plant-based source, then you did not see the effect on mortality. You still saw the effect on cancer, but of course, there was nobody that had a pure plant-based. So most people had a mix. So it's very difficult to have a large population that has a high level of protein, all plant-based. So I don't think that those data are very conclusive. And even when we did the follow-up study with Harvard, it's hard to get a population that is got mostly plant-based source of proteins, and at the same time has a high, let's say over 20% of calories coming from protein. It's almost non-existent. Also because it's so hard to get that much protein from a plant-based diet.
Right, exactly.
So if you're on a plant-based diet and maybe eat fish a couple times a week, you don't even have to worry about having too much protein. It's almost impossible. You will need like a kilogram of chickpeas get into the 100-gram level that might be detrimental.
So you feel like 100 grams per day could be detrimental, even of plant-based protein?
Yes.
Okay, got it. Yeah, so
that's what the data suggests. Once you get to very high levels, then your IGF-1, insulin, and everything else is going to respond to it. Talk about what happens in the body when you consume excess protein. Well, basically, we know that fairly rapidly the growth hormone IGF-1 axis, so this genes that are involved in growth. They're elevated. And also these intracellular genes, TOR particularly, is increased, its activity is increased. And so, and these are the two major, are recognized as the two major pro-aging pathways, so a set of genes that accelerate aging, growth hormone IGF-1 and TOR. And so, yeah, protein control, both of them. So if you have very high level of proteins, you're going to have high levels of these genes all the time. And of course, with it, we expect, as we shown in our studies, both in mice and humans, you expect to have a high cancer rate. Now, the proof of that is our human studies in Ecuador and John Kapczyk and Andrei Barkey studies in mice. And so, now in mice, there's been many experiments confirming a very potent effect of blocking these genes on cancer, and not just cancer. These mice that lack the growth hormone receptor, which responds to protein, have record longevity extension. Right, they live 50% to 100% longer than normal, and we have shown that people in Ecuador that have the equivalent mutation, they rarely develop cancer. Now, out of 350 people around the world, there's only been one cancer death in these growth hormone receptor deficient subjects, which is unbelievable if you think that the people their relatives, they live in the same houses, they develop cancer like everybody else. So this is nothing to do with Ecuador or the environment, or
right,
just has to
or
do
even
with
the diet. Right?
Well,
just because they don't have that growth hormone receptor.
Yeah. So they basically can eat as much protein as they want, and IGF-1 levels and insulin levels be very, very low.
And this Ecuadorian population, they're very small people, right?
Yeah, they're very small people. So are the mice. So are the yeast that have record longevity. But of course, now we know that we can separate at least a part of the longevity effect from the size. But that tells you that there is a very close relationship between these growth factors and cancer and also longevity.
So excessive animal protein drives IGF-1 and TOR.
And insulin too, I mean, insulin is also partially regulated by growth hormone signaling.
Mm-hmm. And so, but sugar also does the same thing, correct?
Yeah, sugar, this is something that we discovered many years ago, activates the other pathway, which in yeast is called RAS-PKA. And now recently we've shown at least the PKA component is activated by sugar also in mammals, in mice, and probably humans. So we call that the other pro-aging pathway, where sugar activates this protein kinase A. And we think that the high level of protein and high level of sugar together are really driving most of the pro-aging and also pro-cancer genes.
So the most dangerous meal might be the double cheeseburger with a large Coke, right? High protein, high sugar.
Well, yeah, I will add high saturated fats, right? I mean, to make it the terrible meal. And and this also underlines the something that I talk about in the book, the importance of not trying to simplify, fat and sugar, and fat and carbs and proteins, but really understanding that it's much more about the type, the quantity. So proteins are fine, carbohydrates are fine, and fats are fine. It just depends how much and which kind. And and it's unfortunate that people have to face it. I think in the book I try to make it as straightforward as possible. But it's not that hard. But you have to learn it. And it's not enough to say proteins are bad. Well, proteins are not bad. You have to have a sufficient number, probably, of plant-based proteins, and same thing for fats and carbohydrates.
So let's talk about fasting, because I know in your research, starting with observing the calorie restriction and moving on to yeast and mice. The first time I read any of your work, I think, was related to how fasting regenerates the immune system. Can you talk about that process?
Yes, I mean, obviously, this started with many years ago with bacteria and yeast, and the fact that when I starved them back in graduate work at UCLA, they would live longer and they would be very protected. And eventually, that led to showing protection in mammals. But then, the more surprising part was when we showed that it caused regeneration, and it wasn't so much the fasting that caused regeneration. It was the refeeding that caused regeneration, right? And that was probably a trick, that calorie restriction done chronically. So if you eat less all the time, you never take advantage of that. So it turns out that the starvation basically triggers the death of a lot of cell types. And it seems like, in our work on multiple sclerosis, we've shown that it particularly targets damaged cells. So if a cell is an autoimmune or cancer cell, right? A cancer cell, an autoimmune cell, they're preferentially killed by the starvation conditions. So starvation is really a destruction of bad component moment. But then the stem cells are turned on and just standing by. There are just few and they're standing by. Then when you refeed, these stem cells are basically triggered. I mean, they're activated, and they can now give rise to new cells to form tissues and organs.
So the old and damaged and weak cells, you're saying, basically die off first during starvation or fasting, and then stem cells are switched on, and then as soon as you start eating again, then they ramp up production of brand new young cells, including immune cells. But it's probably system wide, right? They're probably reproducing organ cells and muscle cells and everything, aren't they?
Yeah, it's clearly system wide, and it's also both cellularly and intracellularly. So intracellularly, it happens by autophagy.
Yeah.
So the cell eats itself, and cellularly, it just happens by clearing and killing cells. And you can imagine, I always use the analogy of a steam train, and the steam train wood that burns wood and running out of fuel and not being able to make it to the next station, and where the engineer basically makes this decision, let's start burning components of the train to make it to the next train station. And of course, if you were that engineer, you pick first the damaged part, the damaged seats or the damaged walls. Anything that is damaged, you burn first. Eventually, then you got to burn everything else. Otherwise, you're never going to make it to the next train station. Now, when you get to the train station, then you can rebuild the train. Mm-hmm. And I think it's a good analogy for what's happening, and it also tells you that this has been around since the prokaryotes, so since the very fundamental forms of life, with autophagy in bacteria going on, and basically the bacteria making the decision, well, there is no food coming in from the outside, let's use the components that we don't need right now to make it to the next moment where we can feed again.
Would you say it's a relatively reasonable assumption that because we have such an abundance of food, right, in the U.S., because we're eating 3 meals a day, every day, that autophagy is not happening very much, or not as much as it should, in our bodies?
We used to eat 3 meals a day. That's what also I talk in the book about. In the book, we eat like 5 or 6 meals a day now.
Well, good point.
Because that's the recommendation. And, it's entertaining that, in a country, the United States, where 70% of the people are overweight or obese, we're still talking about eating 5 or 6 times a day. They haven't figured out yet that that's a bad idea, And in the book, I talk about, somebody overweight or obese should go back to 2 meals a day, and plus maybe 100-calorie snack. So there is no doubt that we are now in an eating epidemic, essentially, right? So the human body, like the bacterial organism, are used to having fasting, starvation being a major portion of the life. And so once you remove it completely, most people, they get headaches when they fast. And I mean, I don't know, some of it might be due to caffeine withdrawal, but some of them we also suspect is due to the fact that some of these enzymes that are starvation response enzymes have never been used in their entire life.
Wow.
I would say most Americans, or Europeans for that matter, have never used a lot of the, for say, brain enzymes that are using ketone bodies for fuel. So the brain usually is fueled by sugar, and when you starve, at a certain point, the brain and other components of the body are now using these ketone bodies. This is where ketogenesis, the word ketogenesis, come from, or ketogenic diet. Mm-hmm. And so the body now is starting to use these ketone bodies. And for a lot of people, we suspect that some of these enzymes have never even been turned on. So I think that we also suspect that the starvation may have represented a moment like sleep, right? Sleep. I mean, we just didn't used to think much about sleep, but sleep is probably representing a moment where, you're regenerating certain things at least. And starvation was probably the same thing. It was probably represented a moment where you stop, ingesting food and use that period to clear up damaged components, turn on good stem cells. That's another thing. You just don't turn on, we suspect at least, you just don't turn on any stem cell. You turn on the good ones. There's probably a selection process to say which one is so healthy that should give rise now to a newly regenerated set of cells, and there's probably we suspect a selection of that. So starvation probably represented this a very important moment in somebody's week. So this probably happened all the time, and now we completely eliminated it. So to the point that people may not encounter it for years and years and years.
And there's a certain amount of time that has to transpire before you switch on this protection and survival mode in your body, right? I mean, intermittent fasting is not enough time to trigger this. It needs to be at least 3 days. Is that right?
Yeah. I mean, first of all, I hate the word intermittent fasting because it doesn't mean anything.
Yeah, I agree.
It's like saying intermittent eating. Well, what does that mean? Of course, people fast. That's why we have a word breakfast, right? You could go 2 hours without eating, and that's fasting. Yeah. Is that intermittent fasting because you had lunch and then you had a snack at 5? Is that fasting between? It doesn't mean anything. So I think it'd be good to stop using it or to start qualifying. So are we talking about 16 hours, 12 hours? Are we talking about eating 500 calories every 2 days or whatever? Right. So each have very different effects. I don't really regard any of that as fasting at all. For the purpose of aging and protection and killing of cells that are damaged, et cetera, like you just pointed out, you need a couple of days. Why? After a couple of days, the glycogen reserves are depleted, and the body is starting to break down its own components, and the body is also starting to switch from a glucose-based metabolism to a fat, and mostly, as we've shown in our papers, is starting to use the visceral fat, right? The fat that is so essential in insulin resistance and all kinds of other problems. So that's like what you want. The belly fat, exactly. Yeah. And that's what you want. You want to start having a preferential effect on the belly fat and not touching the muscle, and even the subcutaneous fat is not really touched very much by the fasting, the prolonged fasting. So, of course, I don't want to. Some forms of what what Sachin Panda calls time restricted feeding is very important. But in the book I talk about 12 hours. Why 12 hours? Well, because 12 hours, if you look at the literature, there are really, so if you eat, say, 8 a.m., 8 p.m., 9 a.m., 9 p.m., and then stop, that's very good. The centenarians do it, and there is not a single study that I could find that shows that to be negative. When you get to eating more than 12 hours, then you start seeing the negative results. But when you get to eating less than 12 hours, you start seeing the negative results too. For example, gallstone formation and the need for surgery goes up dramatically for people that consistently fast for more than 13, 14 hours a day.
Really? So people that maybe skip breakfast and they just eat lunch and dinner?
Well, that's even worse. If you skip breakfast, there are multiple studies, and we have our own data supporting that you increase overall mortality and you increase cardiovascular disease mortality. So if you go over 12 hours, it's already a bad idea of fasting. If you go over 12 hours and you skip breakfast over and over and over, the epidemiological studies show increased mortality, right? Not better, but and it's unbelievable how even experts that I talk to, almost nobody knows this data.
I've never heard that either. I'm fascinated by that.
Ketogenic was one of the most searched and fasting, most searched topic of the year on Google, and nobody knows these facts. It's just scary because obviously imagine the consequences of like millions and millions of people now adopting these things without knowing what they're doing.
Yeah, I'd love to talk a little bit more about the ketogenic diet too, compared to the fasting mimicking diet. But I'd like to talk about the fasting mimicking diet first. So you, I'm gonna, based on what I read in your book, I'm gonna summarize. So after doing fasting research, you realized how powerful it was, but I'm assuming that you also felt like it was maybe difficult for a lot of people to embrace, right? To not eat for 3 to 5 days. My community is very motivated, and they will do it. Many of them have done 3 to 5 days on water.
You'd be surprised. This is why we started the fasting mimicking diet, because your community, the cancer community, didn't want to do it. So we started 10 years ago a clinical trial at USC, and the cancer patient basically said, "I'm not doing this." And the doctors, the oncologists say, "I'm not going to ask my patients to do it." So that was really the motivation to do this. Now, of course, you may have a special crowd that is very motivated.
I think I do.
Sir, but also very motivated to do fasting. Yeah. So they are out there, and they're usually the ones that contact us. But if you grab 100 cancer patients, I would say, well, actually, we did that. We surveyed that, and I think it was
maybe one of them would do it.
7, 8 out of 10 would say, "I'm not going to do it." Yeah. You know what? The interesting thing was they felt cheated. They felt that, why are you giving me water? This couldn't possibly be good for me. And and then we realized also problems with it, right? It's just it may get the levels of blood pressure too low, level of glucose too low, et cetera, et cetera.
Especially if they're taking medications, right?
Well, if they're taking medication, that could be even worse. But even without medication, we see people on a water-only diet. They get, they may pass out, or again, you have to think about the masses, right?
Right.
You take 10 friends, and they all can say, "Oh, I didn't have that problem," but and also because especially if people have been doing this for a long time, sometimes people grew up doing it and they have no problems. But most people, if they're introduced to something like this, they're gonna struggle. Water only, 95% of the people are gonna struggle.
Yeah, I understand that.
And a percentage of those are gonna have real problems.
So, so you obviously realize that people don't want to do it, right? It's hard to convince them to do it. And that led you to develop a fasting mimicking diet.
Yeah, so the government actually, the National Cancer Institute, realized that this was very promising, and so eventually they gave us grants to develop a fasting mimicking diet, and that's what we did, and of course that changed everything. Now we have many clinical trials ongoing on the fasting mimicking diet and cancer, and some of them are completed, and some of them are ongoing. But hundreds of patients have done it, and that's pretty straightforward. One thing that we realized with the fasting mimicking diet is something called food aversion. People don't like, cancer patients associate the diet with the chemo, and so now we realize we have to rotate. So you cannot give them the same thing twice. And so now that's what we're trying to develop now, enough of a variety so that they don't associate any particular food with the pain or the suffering of chemotherapy.
That makes a lot of sense. Can you talk about what the diet looks like?
Yeah, the diet is basically the version that we now have for cancer patient. Well, we have one.
I know you have two. You've got Prolon and chemo
Yeah,
leave, right?
yeah. Prolon is, say, for people that don't have diseases. I mean, really is from a scientific point, I can say it's definitely cancer prevention, a cancer prevention intervention. The FDA will not allow that claim, so it's not a claim because the FDA basically says, well, if you want to say it's cancer preventive, we've shown that in mice, but of course in humans we haven't demonstrated. So, you will have to have a formal trial, which will be impossible to do.
Yeah, you have to follow people for decades.
Exactly right. So it's an impossible thing to do. But yeah, so Prolon is for normal people and people with may be at risk for cancer, at risk for disease, for diabetes, at risk for cardiovascular disease, neurodegenerative disease, etc. But otherwise normal. And Chemoleave instead is something that we developed specifically for cancer patients. And now it's undergoing trials in many different hospitals.
And the Prolon, so it's 5 days, and the first day is 1,000 calories, and then days 2, 3, 4, and 5 are 800 calories, right?
1,100 calories on day one, and
Okay.
then I think 750 day 2 to 5.
Got it. And then, but chemo leave is less. What is it? What's the calorie
Chemo
count?
is less. I think it's something like 600-700 calories on day one, and then it drops down to about 300 calories on day 2, 3, 4. It's only 4 days, and we made it to try to fit more a lot of the different cancer therapy regime.
And can you talk about what the preliminary and even the published results of the human trials you've done on people following this kind of diet, cancer patients following this diet, in terms of chemo working better and it protecting them from side effects?
Yeah, now we've done, there are multiple studies. Some of them are unpublished yet, but, so far they're all positive, meaning that they're all showing protection of either the patient or of the cells in the patient. Sometimes, it's hard to determine, is a patient doing better? So we look at, let's say, DNA damage in the normal cells, and, these, of course, could turn out to be a secondary tumor if you don't protect the normal cells. And so far they're all positive, and now we have to wait for the final results of the 200 people trials.
When do you think that? When does that trial? When does that complete?
Ours at USC is gonna be completed, I think, the next 6 months, and is together with Mayo Clinic and MD Anderson Cancer Center, and then the one at Leiden might take another year or so. University of Leiden. The good news so far, there has been definitely no issues with the diet, meaning that there was people could do it. It was safe. It was feasible. So that's good news, and there is no evidence of problems caused by it. Now, eventually, we have to figure out, is it like we did in mice? Is it making it not just the protection of the patient, but is it making it worse or much worse for the cancer? We suspect that it does, but that part to prove it is much harder because there's so much variability in the cancer patient. It takes so long to monitor cancer progression. But that's what we're also doing now, and we have to see what the results are.
So for the average person who's interested, and I've done the Prolon 5-day fast, and my experience with it was very good. I mean, I didn't find it difficult at all, and the food tasted good, and yeah, my wife and I did it together actually, and we just 5 days did it. How did you arrive at 5 days?
Well, it was really a combination of looking at the effects on IGF-1 and something called IGF-PP1, glucose and ketone bodies. So we wanted to have strong effects on those and really revolutionize the environment to be like a full fast response. We also wanted to push the system, the human body, into a breakdown mode, but we didn't want to push it over the edge, right? So we didn't want people to we didn't want to be so long that people will start saying, "I'm not going to do that." So 5 days, we think is the perfect amount. So you say you start on Sunday, you finish it by Friday, and also obtaining all the things that we want to obtain. For example, the beginning of clearing of damaged cells, the turning on of stem cells, and the breakdown of visceral, of belly fat. The minimal effects on muscle, which is then reversed during the refeeding, et cetera, et cetera. I mean, really, if you look at our clinical trial results from the Prolon, it's really remarkable and how it can have all these positive effects with really so far minimal side effects. And now I think over 20,000 people have done it in multiple countries.
Wow.
And so the good news is we really have seen rarely any problems, and we suspect that maybe none of the problems are caused by the major problems are caused by the fasting-mimicking diet. So that's very good news. Yeah.
So can you compare the fasting-mimicking diet to the ketogenic diet?
Well, the fasting-mimicking diet is a ketogenic diet, right? So meaning that it's a high-fat, low sugar, relatively low protein or low protein, and so can be the ketogenic diet, right? So the ketogenic diet, you have multiple versions. Now, a lot of the ketogenic diets out there are high protein, right? And again, we're going back to these words that don't mean anything. There's a lot of way to promote ketogenesis. I think the fasting-mimicking diet promotes a natural ketogenesis. So it makes the body activate its own fat breakdown. A lot of the ketogenic diets out there are artificial ones, and they impose an artificial condition, which is, let's say, high fat, maybe a lot of it is animal fat, and then high protein, and a lot of it is animal protein. So now, you could go very quickly from something very good to something very bad, And now something very bad doesn't have to appear as very bad when you first do it. It could be that you do it and you lose weight and you think, oh, well, this is great. I feel good. I'm losing weight. And then eventually you could start having, kidney damage. You can start, let's say, have effects on IGF-1 and potentially on atherosclerosis and plaques formation, et cetera, et cetera. I'm not saying that, it does this because there are different ketogenic diets, but I'm saying that, a lot of these diets are improvised. They have, in the book I talk about 5 pillars, which is epidemiological studies, clinical studies, basic research, studies of centenarians, and studies of complex systems. And I do that for a purpose because I basically say, look, when you try to build a space shuttle, you have all these engineers and you have NASA involved and the top universities in the world. And then when it comes to, telling the world or people what to eat, anybody can have an opinion, And a lot of these ketogenic diets are just come from nowhere, but they're able to convince, in some cases, hundreds of thousands of people to do it. And it's not clear where they come from. So I would say let's stop talking about intermittent fasting or ketogenic diet, and let's start talking. It doesn't have to be necessarily the fasting-mimicking diet, but let's start talking about 5 pillars. Where's the data supporting this specific diet? And let's not call it ketogenic. Let's call it something. Let's say this is it. Let's say, does it have 60% fats? 30% carbohydrate and 10% protein, that's a ketogenic diet. That's probably a decent one that you can do for a short period. I wouldn't do that for a long period. In the book, I talk about the ideal diet, again, based on the 5 pillars, is 60% carbohydrate, but not sugars or pasta and bread, carbohydrates coming from fruits and vegetables.
Yes.
Mostly vegetable and legumes and some fruit. So 60-30-10, I think, by looking at all these pillars, seems to be the ideal condition. So 60% carbohydrate, 30% fats, and 10% protein, mostly from vegetable sources.
Well, I'm glad to hear you say that, because that's exactly the way I eat. That's my caloric breakdown, and it is from whole food, plant-based sources for the most part. Isn't it true that the ketogenic diet does not induce the repair and protection mode in the body because you're eating too much food and your body knows you're not starving?
Yeah, I mean, if you think about the train analogy, if you have a lot of food, the body after a very short time adapts and says, okay, we have energy coming from a different source, and so you can have minimal effects on sugar levels and everything else, and there is no reason to break anything down because there's plenty of nutrients to keep going as it is. Now, it depends what ketogenic diet it is. In some cases, you may have a breakdown effect, etc. We do know that certain high-fat diets can promote stem cell-based stem cell activation. But again, really, if you look at evolution and you look at where these programs come from, they come from starvation, right? And you can have a fasting mimicking diet that is very much representing everything that goes on during starvation, including a severe restriction of calorie, right? I mean, the FMD is severely restrictive. So you're fooling just a little bit the system, but other than that, you're just allowing the natural process to occur. You basically don't interfere with the natural process. I mean, that's a key of the fasting mimicking diet. In the case of the ketogenic diet, instead, you're trying to force the system into doing something that has never evolved to do. I mean, we if you think about somebody maybe having a high fat, high animal protein diet by hunting, 50,000 years ago, that wouldn't necessarily need to lead to the breakdown of anything, or the replacement of anything. There's plenty of nutrients coming in, and let's keep going, and this is a moment, in fact, to be very active and keep hunting. If you have that kind of food, keep using that strength and energy to function as fully as possible. So yeah, I suspect that a lot of these things are interfering with these incredible programs. If you look at, for example, our paper recently on diabetes, and we destroyed the pancreas of mice, and then we start the cycles of the fasting mimicking diet, and we show that it turns on the embryonic, the gene expression profile that you only see during embryonic development, right? And so that's extremely powerful. Why? Because imagine having to replace, and we show that we can regenerate the insulin producing beta cells. So we can first destroy them and then regenerate them, right, to normal levels so that they can control glucose level. So to reproduce that with an artificial diet or with genetic or stem cell intervention would be almost impossible. This is a very sophisticated program that has always been there. So it's an evolved program, and that's really what we should exploit, the ability of the body to repair itself. And if you start imposing diets that are, trying to trick the system in an excessive manner, and then
like taking exogenous ketones, for example.
Yeah, I mean, again, if you took some exogenous ketones, well, first of all, let's say you took some exogenous ketones, but you starved otherwise, it may be okay, right? Maybe I wouldn't do it because it's unknown what using ketones like that, ketone bodies for long periods will do. But that could work in terms of allowing these programs to be turned on. If you instead take on ketone bodies and at the same time eat a normal diet or fairly normal diet, then it's a recipe for disaster, because all of a sudden now you're pushing the body. Not only is it not going to work, but you're pushing the body to do to have two metabolic strategies at the same time, and that could be problematic.
Well, that's what's happening. A lot of health influencers are telling their followers to take exogenous ketones and eat tons of bacon, butter, and eggs and avocados, a very high fat diet while supplementing ketones. And yeah, it's just kind of like the Wild West right now.
It's very scary, and almost guaranteed failure, and why? Well, because we're not used to that, and even if it was a good thing for 1, 2, 3, 4, 5 years, eventually the body is gonna have problems, because it's never done that, it's not used to that, and it when you introduce an environment that has never been seen before, sooner or later the body starts not being able to function in that environment.
I'd like to just touch on the results of the human clinical trial that you mentioned earlier. So you had patients do the fasting mimicking diet for 5 days per month for 3 months in a row, correct?
Yes.
And this was how many patients? 10,000?
No. This was 100 in the randomized trial. Was 100 patients.
Got it. So 3 months in a row, they did a 5-day fasting mimicking diet, and then went back to their normal diets for the rest of the month. And yeah, the results are amazing. I mean, they had lower cholesterol, lower blood pressure, they lost weight, lower blood glucose, lower IGF-1. What am I missing?
Yeah, I mean, lower triglycerides and blood pressure, etc. So yeah, I mean, I think that well, first of all, if people had very good levels of let's say cholesterol or blood glucose, it didn't come down anymore, right? So this is also very important, because if you have a fasting glucose of 70, like if you do calorie restriction, that's going to come down to 50, right? And it causes a problem, and we know that. With the fasting mimicking diet instead, it didn't lower it, it left it where it was. In fact, in some cases, even increased it. So that's very interesting because it basically says if the body is functioning properly, there is no reason to fix anything. But if something is dysfunctional, let's say you're pre-diabetic, you're insulin resistant, you have systemic inflammation, then in the great majority of cases, those problems were eliminated or certainly reduced, and the patients start doing better or much better. So that's also a very interesting component of these cycles of the fasting mimicking diet. They're not driving everything down, but they're able to, we believe, repair what's not functional.
That's interesting in that example you gave, because what you're saying basically is that that particular example would be someone whose fasting blood glucose was a little too low, and it came up.
Yeah, so some of the people that had very low fasting glucose came up.
Yeah,
and that's important, right? Because now again, you can go from a problem to a worse problem, and you don't want that. You want the body to be healthy. You want the immune system, for example, to be healthy. And when you have too low levels of glucose, of IGF-1, et cetera, now you can start having important components of the human body shutting down or not acting as quickly as possible. Now imagine if your immune system is if you imagine the battle with viruses and bacteria, I mean, it's always a equal battle almost, right? The immune system barely makes it, and a lot of times we need antibiotics, right, to make it. So that tells you that even if you take the immune system and you decrease its function by 10%, now you just give a big advantage to the virus or to the bacteria, and that could kill you, right? I mean, literally. So yeah, this is why it's so important that levels of many different factors are not going down to too low ranges, because that could be almost guaranteed to be detrimental.
How often do you do a fasting mimicking diet?
I follow my own advice. So, I mean, I have a vegan pescatarian diet, and I follow everything else, low protein, etc. So I do it twice a year. Okay. And that's what I recommend in the book. If you're obese and I have a high cholesterol, high blood pressure, etc., you need to do it once a month until you move to a different range. If you have an ideal diet and you're healthy and none of your markers are out of range, then twice a year is sufficient.
But do you recommend that almost everyone do that initial 3 months in a row, and then twice a year beyond that?
Not necessarily, no. I think that if you don't have any problems, you can probably go to, let's say, once every 4 months. If you have, let's say, maybe a little bit high cholesterol, you want to drive it a little bit lower. You can do it once and then wait 4 months and do it again. And then if it doesn't work, you can do it more frequently. Or if you feel great and all your markers are great 4 months later, you can do it every 6 months. Go to the 6 months. I think it should be done in a need to do it basis. On a need to do it basis, it shouldn't be done just as frequently as possible. Not until we know more about it. I think eventually when we can do an epidemiological study and say the people that are doing FMD once a month, they're living 10 years longer than everybody else. Okay, then we'll tell everybody do it once a month. But until then,
keep me in mind. I might sign up for that one.
Yeah, there you go.
That's great. Well, Dr. Longo, I really appreciate your time. Thank you so much. This has been really fun. I want to ask you one more question. This is more of just a fun question. But if you had to eat the same thing every day, this breakfast, lunch, and dinner, for the rest of your life, what would your day look like? And breakfast, lunch, and dinner can be different meals. But what would your ideal, I'm stuck in the biosphere diet.
So I think I probably would be what I eat for breakfast, which is a black tea and green tea together, and I put a whole lemon in the tea, and then I have a cinnamon raisin toast with blueberry preserve in it, low sugar, and then for lunch, probably a ideal would be a salad. A salad with as many different components as possible, and then dinner. What I have almost very often is let's say about 50 grams of pasta, and then about 350 grams of wet garbanzo beans, and then another couple hundred grams of mixed vegetable like corn, carrots. So it's like a minestrone, and I put a ton of olive oil on it. So that's something that I do eat all the time. And if you look around the world at the centenarians that are so successful in making it to 100, it's unbelievable how much they ate over and over and over. Like you just pointed out, the same
thing every day.
Same food. Like the Okinawans used to eat sweet potatoes all the time. 70% of their calories came from these purple sweet potatoes. And the southern Italians from Calabria, where I spent a lot of time growing up, almost every day they ate this pasta and vianea, which was a little bit of pasta and a ton of these green beans. So I think it's also something important to tell your audience. Not necessarily to try to go to too many exotic foods, but maybe pick the 30 healthy foods that your grandparents used to eat and just stick with those.
Eat like your ancestors, right?
Well, not necessarily. Start with the right list and then go see, because some people's ancestors had a very terrible diet.
Yeah. Good point.
Yeah, pick the right food and then go out of those and see which ones your grandparents used to eat. Yeah.
That's great. I love it. Okay, well, thank you so much, Dr. Longo. I will provide links below this video, everyone, to find out more about Dr. Longo's research, about the Prolon fasting-mimicking diet, and a whole lot more. Thanks so much for watching. Please share this.
The longevity diet, and all my royalties at least go to the Create Cures Foundation to continue this type of research. And really, now we have a lot of trials that are going to be sponsored by the book royalties in Italy and Spain and elsewhere. And I hope it does very well in the U.S. so that we can continue to do this. Yeah.
Thank you for bringing that up. That's great. So yeah, all the proceeds go to nonprofit Create Cures Foundation. And pick up a copy of The Longevity Diet, Dr. Longo's book. I have it on Kindle on my phone and read it this week, and it's awesome. Just a fantastic book, especially if you love this kind of research and you're a fan of the blue zones. you will really enjoy the longevity diet. So thanks everybody for watching. I'll see you on the next one.
Thanks, Chris.